Welcome back to The Explainer. Today, we're going to peek under the hood of the AI speed machine. We're diving into the raw performance that makes AI feel totally instantaneous, and the absolutely incredible technology that makes it all work.
So you know how it is, right? You type a question into a model like ChatGPT, and boom, before you can even blink, this detailed answer starts streaming back at you. But have you ever stopped to think, how on earth is it possible for one system to handle millions of us all at the same time without just completely grinding to a halt? Well, the answer, at its core, boils down to solving a massive, planetary-scale digital traffic jam. To get everyone an answer that quickly, engineers have had to invent some truly brilliant ways to keep all that digital traffic flowing smoothly. Okay, so before we can even get to the amazing solutions, we really need to understand the problem. This traffic jam isn't caused by just one thing. There are two completely different kinds of AI traffic that the system has to juggle at the exact same time. On one hand, you have prefill. Think of this as the system processing your initial question. It's like a big, heavy semi-truck. It's slow and it takes a ton of computational power. Then, on the other hand, you have decode. This is the AI generating the answer, one word at a time. These are like a swarm of super fast delivery scooters. They're quick, but they're constantly dipping into memory for directions. Now, imagine trying to run both of those on the same highway. It creates an epic bottleneck. So, how in the world do you solve a problem like that? Well, the first big breakthroughs came from completely rethinking the two most fundamental things: how the AI engine manages its memory and how it schedules all this work. And the first key innovation is a brilliant technique called paged attention. See, the old way of managing the AI's memory, its KV cache, was kind of clunky. Imagine going to a library and having to reserve a whole giant continuous row of shelves, even if you only had a few books. Most of that space would go to waste, right? Paged attention is like a modern digital card catalog. It lets you store your information on any open shelf, anywhere in the library, and it just keeps a simple map of where everything is. Suddenly, no more wasted space. So here's a quick look at how it works. Your prompt comes in and gets broken into little pieces called tokens. The system asks for just enough memory blocks to hold those tokens, not a bit more. A manager then just hands out available blocks from a free pool and creates a simple map or block table showing where everything went. It's just unbelievably efficient because absolutely no memory is reserved ahead of time or wasted. Okay, so memory is sorted. Awesome. But the next big problem is making sure the real powerhouse of the whole operation, the GPU, is always busy. The old way, you'd have to wait for an entire group of requests to finish before you could start a new one. That meant the GPU was just sitting around, idle, wasting time and money. That's where continuous batching comes in. Continuous batching is basically like a super smart elevator. Instead of leaving on a fixed schedule, it just keeps its doors open, constantly letting new people on as soon as there's a tiny bit of space. It's always mixing those heavy prefill trucks and those fast decode scooters on every single trip, making sure the GPU is always packed to capacity and running at 100% efficiency. All right, so now we've got this really efficient core engine, right? But to get that insane speed we all experience, developers started adding some really clever optimizations on top. You can think of these as speed hacks. First up is prefix caching, and the idea behind it is so simple. Just don't do the same work twice. So if you ask the AI, explain quantum physics for a kid, and right after, I ask, explain quantum physics to a grad student, the system is smart enough to only compute the explain quantum physics part once. It saves, or caches, that result, and just reuses it for my request. That saves a massive amount of redundant processing. Okay, this next hack is so cool. It's called speculative decoding. Normally, the huge, powerful AI model generates your answer one word at a time. It's super accurate, but it's methodical. Speculative decoding introduces a second, much smaller and faster draft model that just races ahead and guesses a whole chunk of words. It is literally like having a super fast junior assistant who just bangs out a draft of a few sentences, and then the brilliant but very busy senior editor, that's our big AI model, can just glance at it and approve the whole chunk in one go. The system gets to generate multiple words for the price of one, which just dramatically speeds up the whole process. So all these tricks make a single engine ridiculously fast. But that's just one engine. How do you serve the entire planet? Well, that's when you have to think way, way bigger, coordinating thousands of these engines so they work in perfect harmony. It all starts with one GPU. But here's the reality. Modern AI models are just gigantic. They're so big they often don't even fit on a single GPU anymore. And even if one did, it could never handle the absolute flood of requests coming from millions of users all at once. So what's the solution? Well, you make them work together like a symphony orchestra. The AI model itself gets split across a whole team of GPUs using a technique called tensor parallelism. Then a central conductor sends a piece of the problem to each GPU worker. They all process their part at the same time, and the conductor gathers up all the results to form one single coherent answer. Okay, so let's put it all together. Let's follow your request from start to finish. You hit send, your request hits a server and a load balancer, think of it like a digital traffic cop, instantly sends it to the least busy AI engine available. That engine uses all the amazing tricks we've talked about, page detention, continuous batching, all of it, to generate an answer, which then flies all the way back to your screen. And this all happens in the blink of an eye.
But here's the thing. Running a system this complex isn't just about pure speed. It's a constant, delicate balancing act. There's a fundamental trade-off that every single AI service has to deal with. And that balancing act really comes down to two key ideas: latency and throughput. Latency is pretty simple. It's how long you have to wait for your answer. Lower is better. Throughput is about the whole system. It's how many total tokens the system can generate for everyone at once. Higher is better. And here is the absolute kicker. You cannot maximize both at the same time. It's impossible. Optimizing for one always hurts the other. Think of it like this. You can build a single-lane Formula One race truck. One car can go incredibly fast. That's super low latency. Or you can build a 10-lane superhighway. It can move way more cars at once, even if each individual car is going a little slower. That's high throughput. So you can see the trade-off here. If you tune the system for low latency with really small batches of requests, one user gets a lightning-fast response, but the system's total output is pretty low. But if you tune for high throughput with huge batches, the system becomes an absolute powerhouse. But every individual user has to wait just a little bit longer for their turn. So for the people running these massive AI services, it's not a set it and forget it kind of deal. They are constantly auto-tuning these systems in real time, trying to find that perfect sweet spot that keeps all of us users happy without wasting a single cycle of that incredibly expensive GPU hardware. You know, this quote from Alexa Gordich's amazing deep dive on this topic really just nails the whole story we've just gone through. You start with the core engine, you layer on those clever features and speed hacks, you scale it up across many GPUs, and then you scale it out into a global system that can serve the world. So, from solving a crazy digital traffic jam to building what is essentially a global brain, the engineering that makes AI feel instant is just breathtaking, isn't it? And it leaves us with a really fascinating question. As these systems get exponentially faster and more efficient, what new possibilities are they going to unlock? What happens when instantaneous AI is the foundation for everything we build?